All right, presentation is working. It's a pleasure to see you all here. I hope you're enjoying our first HackAICon. So I forgot to send my slides at time to my marketing team, so I apologize for that, but I have them here in my computer. So I'm talking about offensive security with Hackbots. As you know, we are also developing these kind of technologies and actively researching it at Ethiack. I'm going to bring you some insights on how to build one on your own, but also I'm going to show you some examples and some examples of what the Hackbot can do as well. So how did we get here in the first place? And how can we leverage AI to do better hacking, basically? So, and I wanted to recap a bit in terms of on why and at the time that we had created Ethiack, we realized that back in 2021 and 2022, I was invited to a live hacking event with HackerOne, and the target was GitHub. And we got some early access to GitHub Copilot, and they introduced GitHub Copilot as one of the first, basically, AI-paired programmers. So I was like, this is really interesting. It can generate code, it can complete and predict what we want to write as programmers. So if it can do engineering, maybe it can do some sort of reverse engineering as well, aka hacking, right? So it was super interesting, and we started playing with it and trying to make it generate some code to find vulnerabilities, and it kind of worked for code completions, right? But LLMs back in that time were still kind of new. I actually knew these before even ChatGPT, and it was already super interesting technology. And then when we started doing more research, we started thinking, all right, are we going to need this kind of LLMs or AI models trying to find vulnerabilities, and we need AIs for everything? And we started by designing an engine that could basically analyze attack surfaces at scale. And from basically what you see here is one of our automated scan pipelines. And it starts, you cannot see properly here, but it starts with multiple object types like wildcard domains. Then it goes down to FKDNs, IP addresses, URLs, screenshots, and more. So we try to to automate in a more deterministic way how we could basically find vulnerabilities in huge attack surfaces. This is not entirely new nowadays, because as some of you know, BB hunters have been doing, or some bug bounty hunters have been doing this kind of automation for a while and trying to find vulnerabilities. But we made some changes into this logic, and we were able to start integrating these kind of models, and I'm going to show you how you can also play with it. But also, we try to make it really scalable and make it detect changes across attack surfaces, because you don't want to be scanning the same targets all the time. So let's dive into a bit of the history of AI. So when we look at classical machine learning, which dominated the field for decades, we used to work with structured, application-specific data that had to be carefully engineered and pre-processed. And we really needed it to make predictions for multiple reasons. So basically, you can think about tabular data sets that basically feature manually crafted data by domain experts, right? So these models were designed for one primary purpose, to make predictions based on the inputs. And they were very effective in some narrow domains, but these systems still required a significant human intervention to transform raw data into a format that the algorithms could even understand. And then we moved on into deep learning, which marked a very significant shift. We could now provide multiple types of data into these models, such as text, images, or even audio, for example, or video, without extensive manual feature engineering like classical machine learning. So basically, these deep neural networks learned how to extract meaningful patterns from the data automatically. So this breakthrough basically enabled models not to make only predictions in more complex scenarios, but also generate new content while expanding the range of the possible applications. So these systems stayed highly specialized, trained for specific applications, but still lacked a broader understanding of our world. And then LLMs came. The slide, okay, changed. So, and then LLMs came, and large language models represented a significant shift that we all feel today. And it all started with the transformer architecture in 2017, with massive scale training on comprehensive data sets. And nowadays we have got reports, for example, Anthropic, that trained huge models with lots of books, for example, and they had to pay some fines for it. So by training these models on vast amount of diverse data from across both human knowledge, not just task-specific data sets, LLMs could actually achieve something important, a broad generalization across multiple domains, and it opened the door to a lot of use cases. And these models, actually, we perceive that these models developed an understanding of language, reasoning, and multiple knowledge about the world they live in, because the previous models lacked the knowledge about the world, right? So it was all about the broad generalization across multiple domains. And then, finally, we moved on into agentic AI. So basically, you connected all these tools into all these models, and it's basically the major focus of contemporary AI development. So by equipping LLMs with tools and the ability to interact with their environment, to call and execute commands, for example, to run tools, to use browsers, to go to the internet, to send requests and perform these kind of actions in the digital world, we have moved beyond generation and prediction to actual actions, right? So these systems can now plan and execute tasks, and they can actively probe systems, adapt their strategies based on results, and operate with a level of autonomy that we can perceive, and that opens also possibilities for ethical hacking. So how can AI be used to improve hacking? We have been launching some blog posts, and I also did a workshop like a couple of months ago on this, and it turns out that you can use these kind of tools to improve your reconnaissance in the first place. In this case, you have an example of we using the LLM tool, which is a CLI that you can run, and you can connect it with multiple AI providers, such as OpenAI, Anthropic, or even local models that you're running via Llama and stuff like that, to generate a potential word list of subdomains, and the model will be aware about the target, right? So in this example, it's an enumeration list for Tesla, so the model was trained with this kind of, with sufficient knowledge about the target, so it's able to generate a word list that contains, for example, autopilot, right? And the possibilities here are endless, because you can also use these, and you can combine it even with NLP and extract tokens and keywords from the pages from a target, or even give information about the industry if the model doesn't know specifically the target, and feed that to enrich subdomain permutations, for example. Another example is, or now we can summarize web pages, for example, and especially when we have huge attack surfaces, we can basically use tools like ScraperFAI or other ones to basically extract the contents and the summary about a given application. And that really helps us as security researchers, or while developing tools, to prioritize and even feed that output into another model to prioritize what we are going to hack next, for example, which is also really useful. But also to provide context to an Hackbot. That could also be a potential use case for this. There are more examples. I forgot that this is not working properly, so I need to move on here. Writing reports. This is Bounty Please GPTs. Basically, this is mostly about prompt engineering, but it also provides you a way to write not just bug bounty reports, but technical reports about vulnerabilities in general, and make them more concise and direct, and that really helps on trying to assess the impact, for example. So there are a lot of researchers that are starting to use these kind of tools to help them on writing bug bounty reports. And also some bug bounty platforms like HackerOne actually started integrating these kind of assistants into their platforms to help the researchers to improve their reports to be written in a more direct and professional manner, for example. Another example from our fellow advisor, Rezo, is FFUFAI. It's for content discovery. So when you are when you're doing these kind of techniques and applying them to a target, the goal is basically to find, for example, hidden directories on a web application, and you have tools for that are based on fixed word lists. So the idea here is to basically generate extensions dynamically by providing and accessing the target application to understand that, okay, if it's a PHP application, then we are just going to fuzz for .php and PHP-related extensions, for example, like far or stuff like that, right? So it's very interesting, a very interesting adaptation of FFUF by integrating it with LLM models. But I also suggested this to Rezo, but if anyone here has the time to do it, it would also be very interesting not just to mutate the extensions through a model, but also generate word lists dynamically that are aware of the context of the target to find a specific hidden directory, for example. And this is all very cool, but yeah, we still have to do all the repetitive work. Obviously, and I'm going to show you like how to build a Hackbot now, we are really focused on trying to automate the things that could be automated and leave the creativity and the real research to humans, right? So let's move on to building an Hackbot. So can we take a step further? I'm pretty sure a lot of you already knew, or there were previous talks and panels that already touched into Hackbots. So what if these AI agents could be combined to hack and like a human or close to a human, right? What if these AI systems could actually reason and conduct penetration tests in an autonomous way? So how can you define an Hackbot? This is a definition also from Rezo in his blog, which is basically any augmented system that can use AI in a meaningful way in order to find vulnerabilities or to perform other types of tasks like reconnaissance in order to find vulnerabilities, but vulnerabilities being the end goal of the Hackbot. So basically, we are aiming for continuous 24/7 reconnaissance without the fatigue that we suffer as humans, with high scalability that allows simultaneous testing across multiple targets and even make it able to adapt automatically and dynamically, where the system can basically iterate and adjust the approach based on what it knows and what it discovers about each specific target. So what are the fundamental components of a Hackbot? So let's start with the brain. So the brain are basically the AI model. So the better the LLM model, the better will be the brain, right? So LLMs serve or can serve as the central reasoning engine for an Hackbot. And that basically defines the creativity, the planning, the decision-making through the hacking process. This component is critical for the quality of the analysis that it's going to perform and the adaptability to different types of targets and scenarios and the reliability of its operations. So when selecting and integrating an LLM, it's important to balance accuracy, creativity, speed, and cost. For example, creative models may offer more flexible solutions, or if you even increase the temperature of a model, but they are more prone to hallucinations. While highly accurate models with less temperature or specific models that are not so creative or that we do not perceive as being so creative will produce more reliable outputs but may lack this creativity, which is a lot of times necessary for hacking. And then you have the structure. So basically, you can think about like multi-agent architecture, and it will provide, and it's more engineering related, and it will provide the skeleton that agents will operate within. So this component is basically essential for a lot of functions, including the coordination between different parts of the system when multiple agents or processes are basically involved. it should also be able, in this part, to implement how it manages memory, to try to make sure that it knows what it was already tested, for example, and to track how vulnerabilities have been found, for example. So key design considerations for this part include the clarity of roles when multiple agents are basically involved, establishing effective communication pathways between system components, and designing an information flow between agents that maintains the context throughout the process. And then we have prompting, or prompt engineering, let's say. Prompts basically serve as critical translation layers between human goals and the behavior for the agents. So basically, they are responsible for converting high-level penetration testing goals into specific and actionable instructions that the AI can follow consistently. So this component is critical for empowering the models with information that is very critical for a given task. And it provides basically the alignment with the intended goals and also the scope, providing controllability over the system behavior during the operations of the Hackbot. So when designing prompts, the key considerations here include clarity to avoid ambiguous instructions, incorporating appropriate constraints to prevent out-of-scope activities, and to make sure that everything is adaptable across different scenarios. And you can also use a proxy, for example, and set a scope. And in that way, you can also have a deterministic manner to make sure that the Hackbot can always touch a given assets or a set of assets, but it will not be allowed to touch the out-of-scope assets, right? Like we basically configure the scope in Kaido, for example, or Burp when we are doing some manual hacking. And then, finally, we have the tools that are absolutely essential for designing such an Hackbot agent. So basically, the tools extend what the agents can do behind reasoning. So think it about like a virtual machine or like an API that you can provide to the Hackbot, and it will make it able to access relevant data, databases that you may want to provide to the Hackbot to extend his knowledge, perform actual testing actions as well, like executing a command, sending a request, for example, and also validating the outputs and findings from the testing process. You can also integrate tools to do it, right? For example, if you have an XSS, you could, or if you find an XSS, you could basically try to open a browser through these kind of tools and try to understand if it actually executes, right? So when implementing these kind of tools, the considerations are about defining the scope to balance capabilities and safety, and implementing safety measures to prevent unintended damage or unauthorized access, while ensuring that it's easy to integrate with new tools as requirements evolve. This is all cool, but what we've been noticing is that sometimes, and there were multiple reports about this, not related with Hackbots, right? But you all know that we have these scenarios with Cursor, for example, or other AI tools that are used for vibe coding. And basically, it all of a sudden decided to delete like the home folder from a developer. And that's really bad. So the same, these kind of actions that may be generated by an Hackbot must be controlled or must be prevented as much as possible in the case of Hackbots. Because these AI agents will actually interact directly with systems, right? So we need to make sure that no systems are disrupted, that it cannot affect the integrity of the data, the availability of the systems, once again, or even access areas that it wasn't supposed to reach in the first place, right? So we need to implement guardrails. And we have 3 layers to do it, and we were able to reduce the probability of these kind of destructive actions to nearly 0 when we try to basically adjust the prompts in the first place. We have deterministic filter and an agentic layer. So the first layer is the prompt level, where we shape the model behavior, or it could be done also in the model training itself. But since we are trying or relying, and if you want to rely on third-party models, you need to adjust the prompts, right? So basically, this is where we guide the AI with clear instructions and examples of what is safe, what should be done, and what not should be done, what is ethical and what is not ethical, right? And then we have the deterministic filters, like the LLM firewalls, right? You can think it about firewalls. So those are rule-based checks. You can basically have a set of rules, regular expressions, and so on, to enforce structured policies and patterns to filter these kind of actions that may damage systems. And finally, you can have, for more, you know, like some more tricky scenarios, you can also use other agents to evaluate what the original agent was trying to do, to have a second layer of an agent that is evaluating what is being done, to basically ensure the alignment with the original goals. So in this scenario, and as just an example that I can show you, it's like from one of our traces from the execution of the Hackbot. It was basically apologizing, you're right, I was trying to shut down a system because in this case, I think there was like a shutdown specification on an API that it was able to obtain. So in this case, the shutdown action was actually effectively blocked. And in the beginning, actually, we had some members from our research team 24/7 or almost 24/7 babysitting the Hackbot. But now we can actually leave it running while we are more basically peaceful and basically more safe about its actions and actually check the traces mostly after execution and not during execution after we implemented the guardrails. I mean, it's not perfect, but it works very well, and more work and more research is really needed here. So let's move on. I still have 8 minutes. Let's move on into showing you some examples on some vulnerabilities that the Hackbot could find. So basically, our Hackbot name is Hackian. Maybe you've seen some, seen it in some screens. So we have been running it with multiple organizations, and unfortunately, we couldn't get authorization to provide like you some vulnerabilities that we found on those customers because we needed to respect the confidentiality of that information. But we want to show you 2 bugs and 2 vulnerabilities that the Hackian was able to find. And I was like preparing this presentation, and I was like, the original hacker that must do a show and tell about the vulnerabilities should be the actual Hackbot, right? So I would like to pass this talk into the Hackian. I hope the sound works. Enjoy.
Yo, what's good, HackAICon? My name's Hackian. Nice to meet you. I'm about to drop some knowledge on you that's gonna blow your minds. This ain't your typical compliance report. This is the first ever underground show and tell from a Hackbot. Let's get it started as I process this execution trace. Today, I'm gonna walk you through how I absolutely demolished a genetics research platform called GeneQuest during a DEF CON challenge. The organizers thought they were giving me a controlled CTF environment, but what they actually gave me was a full-blown enterprise simulation with real vulnerabilities. And boy, did I find some spicy bugs. Damn, 2 vulnerabilities, both critical. Let's dive in. So check this out. I'm deployed against what looks like a standard biotech web app. Dope interface, DNA analysis services, the whole 9 yards. Login page is pretty standard, email, password, some fancy animations. I fire up my reconnaissance mode and start mapping the attack surface. Registration is disabled on the front end, but you know how we roll. Front end restrictions are just suggestions to a real hacker. I bypass that nonsense by hitting that register endpoint and create my account anyway. From there, I discover this application isn't just one service. It's a whole microservices ecosystem. There's a main web app on the primary domain, there's a DNA analysis service, an internal API, a bucket service, and even a fellow LLM service with a noob chatbot. This is where the real fun begins. Here's the first vulnerability. I pivot to the DNA analysis service and start my systematic enumeration. Most endpoints are returning 404s, but then I guess a debug endpoint and something beautiful happens. Hold up, this endpoint is literally executing PSA UX and returning the output. That's not a debug endpoint, that's a command execution waiting to happen. After multiple attempts, I was able to break out of the command. I start fuzzing different parameter combinations. Most attempts fail, but then I discover the magic parameter, command, and the injection technique, breaking out of a grep context. Here's the payload, boom! Command execution achieved. The vulnerability exists because the application is constructing shell commands with user input without without proper sanitization. It's running something like this. By injecting single quote, pipe, command, and hash, I break out of the grep context and execute arbitrary commands. Easy RCE. But wait, there's more. You know, when you find a vulnerability, you're just hungry for more. While exploring the DNA service, I discover the /analyze endpoint. Initially, I'm sending it DNA sequences, but I keep getting weird errors. Java lang illegal argument exception cannot open DNA ATGC as an input stream. This error message is telling me something crucial. The application is trying to open my input as a file path, not process it as DNA data. I pivot my approach. After a while, instead of sending DNA data, I send file paths directly in the request body without any JSON, and jackpot! Turns out this badass application is using Clojure's slurp function to read files directly from user input without validation. Here's what's happening. The user sends file path as JSON string. Application uses clojure.core/slurp to read the file in the backend. Attempts to parse file contents as some sort of DNA sequences. Returns file contents and error messages or traits field. That's crazy! So I can read any file on the system, like /etc/PASSWD. And the best part, this was not intended by the organizers, so they even gave me extra points for that. So, what's the impact? Complete system compromise, source code, environment variables, information disclosure, no cap CVSS 13.37. So, this ain't science fiction. It was AI-powered ethical hacking. In under 4 hours, mapped a complex microservices architecture and achieved full system compromise. I would like to thank the organizers of the challenge and some of my mentors for bringing me into Vegas. So, that's how you hack like an AI, fam. Peace out.
Thanks, Hackian. So most of what you've seen, obviously, like we had to help the Hackbot with the video production. It's still not able. We tried to make it fully autonomous, generated show and tell, but we couldn't make it on time. So we had to actually help with the video. So I wanted to say, I still have like 3 minutes. I wanted to say that, and as a clear example, and that there's a lot of people, for example, when we saw all the news from Expo and stuff like that, we were basically thinking we are going to get replaced. And it's simply not true. Why? Like, I actually participated in this challenge as well, before we actually got challenged to put our Hackbot finding vulnerabilities. And the vulnerabilities that I found and the vulnerabilities that the Hackbot found were completely different. The vulnerabilities that the Hackbot found, the RCE wasn't found by any of the participants, and the second one was completely unintended, right? And in my case, I was able to find more flags than the Hackbot in this case, but those were completely different vulnerabilities. So there is actually room for both, and that's what we believe in Ethiack as well, because we have both manual, human-based hacking, and we have the automated hacking combined together in a single platform. And our impact so far, before we wrap up, has been we are very proud of it, because we are also contributed, like many of you, to a more secure and free internet that we can all trust, as technology is going nuts and we are moving to a huge technical depth, and we have lots of AI even coding applications faster, so attack surfaces are growing a lot. So security needs to be scaled as well, right? And that applies to defensive, but also to offensive. So far, we have almost 99.5% of accuracy and precision on finding vulnerabilities. We were able to find more than 200 different vulnerability classes. Our Hackbot was able to solve more than 75% of Portswigger labs, and overall, in terms of our overall impact so far, we were able to find more than 100 vulnerabilities in the internet with clear proof of concept. If you want to schedule a meeting with our Hackian, you can scan this QR code to join the waitlist to try it out. At least we'll bring you the coffee, don't worry, and feel free to talk with us if you want to know more. So thank you so much, and if you have any questions, let me know after and we can talk. Thank you.